All right, so 14.6 is combinations and permutations. So the most the most important thing that you need to know about permutations versus combinations is arrangement. So with combinations, we're talking about something the arrangement doesn't matter, and with permutations, we're talking about something where the arrangement does matter. So an example of this would be a combination would be if I had a class of 25 students and I needed to pick 5 students. Any 5 students. It wouldn't matter what order I pick those students in, we just have a group of 5, right? So for a permutation, that's where the order does matter. So for example, if you have a lock, like a lock for a locker, if your locker combination was 1, 2, 3, if you typed in 3, 2, 1, would that open the locker combination? No, so that's where order does matter. So that's the difference between the two scenarios. You're going to also notice they have different formulas. So these are the 2 formulas on the test that I will provide for you. Okay, these are the only 2 formulas I will give you on the test, but they are not going to have context. So I'm not going to tell you which one is combination, which one's permutation. You have to know the difference on your own. Just this side of the formula I'm giving you. So the way that you can remember is the one with the P. P comes next in the alphabet, okay? And with that, I was going to say that doesn't work because this already got, the P comes last and it has less stuff in it, and this one comes first and has more stuff in it. I don't know. Maybe that helps you remember. Maybe it's really not. But with combination, it's going to be n factorial over r factorial times n minus r factorial. That exclamation point in math is what we call a factorial, and I'll explain how that works. A factorial is basically where you multiply the preceding numbers. So like if it's 4 factorial, that's 4 times 3 times 2 times 1. Okay, 5 factorial will be 5 times 4 times 3 times 2 times 1. N is the number of things that you're choosing. So if we're talking about n, it would be basically the number of things you have to choose from. Almost like a sample space. R is going to be number of things you are choosing. Okay, that's what those 2 letters represent, okay? So if you have a class of 25 students and you're selecting 6 of them, 25 is n, r would be 6. Does that make sense? Okay. And 0 factorial is always 1. That's another thing you're going to want to know. So we're going to identify whether each situation is a permutation or a combination. So we're not going to actually solve these, we're just going to identify them. So picking a president, vice president, and secretary from 10 members. So combinations where the order does not matter, correct? If we were to pick 3 different people from the 10 for the president, vice president, and secretary, the order would matter because there's different ways that we could put people in those positions, right? So if I pick 3 people, they could be, one of them's the vice president, one's president, one's secretary. Couldn't I scramble those up and give them different positions? So the order does matter in that case because it matters whether you're a president, a vice president, or a secretary. Those aren't all neutral positions, right? So order does matter here. This is a permutation. Does that make sense why the order here matters? Because these are not of equal value, okay? Arranging 5 textbooks on a bookshelf. So if I am taking 5 books and I'm putting 5 books on a bookshelf, if I don't care about the order, there's only one way to do that, right? It doesn't matter which way I put them. But if I want to have different arrangements, isn't the order I put them in going to matter? So that's going to be a what? Permutation. How does the order matter? Because let's say we have 5 textbooks. We have English, math, science, history, and Spanish, okay? The order is going to matter. So let's say this is the textbook. I have a red, I have a brown, I have a blue, I have green, and I have black, okay? Those are the textbooks, okay? Yeah.
How do you know if it's 5 different textbooks or just 5 in the same textbook?
Because if we're talking about 5 textbooks, if they're going to have you have all of the same, they're going to specify that on there, because you wouldn't assume that 5 textbooks are going to be the same textbook. Otherwise, it would only be one way to do it, because you know what I'm saying? Because like if you had 5 of the same book, they're all going to be the same. All right, so is everybody looking at this example here? I'm going to try to explain it to you. If the order doesn't matter, if we have red, brown, blue, green, and black, that would be the only one and only combination of those things, right? Because we're not choosing from a larger group and selecting a smaller group. But wouldn't it be a different arrangement if I put it in this order instead? And then there would be a bunch of different arrangements that I could put them in, correct? The order that I put them in will matter for the arrangement. Does that make sense? So that's why it's a permutation, okay? All right, picking 3 flavors of ice cream for a sundae. So, if you said to a person in the sundae shop, can I get vanilla, chocolate, and strawberry, would it be the same thing as you saying you want chocolate, strawberry, and vanilla in the sundae? Yeah, so that would be a combination.
Yeah, how is that any different than what you said?
How is it different than the what? Oh, well, yeah, we're not talking about like the stacking of the ice cream, because a bookshelf arrangement is based on literally the order of that arrangement, right? But with a sundae, we're not talking about like how the sundae is arranged in what order. We're talking about an arrangement versus like just getting a sundae with those 3 flavors. Does that make sense?
Arranging, more specific. Arranging.
Arranging is the specifics.
So
Arrangement.
would it always say arrangement then?
Every problem's going to be a little different. That's the thing about statistics that's different than other math that you're dealing with. It is all about context, which does make it difficult at times. So the next one here, some of them are more obvious than others, you're going to notice. But if you guys want to have time to do some homework and not just be the whole lesson for the period, we do got to move it along here. So, putting 3 digits from 0 to 9 into a lock to open it. Okay, that one's a very obvious permutation, right? The reason that this one's an obvious permutation is because if you know your locker combination is 520, you know that 205 is not going to open your locker. So that for that reason, this is definitely a permutation. Very good question. We actually talk about that in college classes a lot. It's incorrect to call it a combination lock. It's actually a permutation lock. So, yes. All right. So now we're going to not only identify, but we're also going to do the calculation here. So it says identify if the situation represents permutation or combination, and then find the number of arrangements for each situation. So suppose you want to know the number of different ways 7 runners can finish in the top 3. So when we talk about the top 3, we're not talking about any specific order in the top 3. We're not talking about silver, gold, and bronze. We're just saying, in general, if you're in the top 3, you're in the top 3, whether you be in the bottom or the end or the beginning of it. So order here does not matter, okay? We're just talking about you being in the top 3 in general. We don't care what level in the top 3 you are, okay? So this is a combination. So you're going to notice this is your combination formula, so this is what we're going to use here. Okay, that's the formula we're going to use, the combination formula. So the combination formula says we're going to take the number of choices that we have, which is what? 7, factorial, over the number of things we have to choose from, or we're choosing, which is what? 3. And then times the number of things we have to choose from minus the number of things we're choosing, which is 4. That's going to be your setup, okay? Now to do this actual calculation, I'm going to show you the easiest way to do it here. So 7 factorial looks like this. It's 7 times 6 times 5 times 4 times 3 times 2 times 1. That's how you do a factorial. So 3 factorial is 3 times 2 times 1. And what would 4 factorial be? Times 2 times 1. So is everybody with me on how we got here? Now, instead of doing all this math out, which you technically could do, what you can do is start canceling stuff out. You're going to notice that there's some commonalities amongst the top and bottom. Like that. So you're going to end up with 6 times 5 times 7 on the top. 7 times 6 times 5, which is 210, all over 6, which is 35. So what the 35 means in context is, if we have 7 runners, and we know that we're going to pick a top 3, there's 35 ways in which the top 3 can occur with those 7 runners. Okay? So any questions about that? Yes?
Is there a factorial left on
Yes, there is actually. If you want me to show you at the end, I'll come over and show you on the calculator if you want to know how to do it. But it is more complicated to know how to use. That's why I didn't really want to show you in class. But suppose you want to know the number of ways 7 runners could place first, second, and third place with no ties. So is this one a permutation or a combination? Permutation. Do you see the difference between the two? One of them's talking about specifically being in first, second, and third place where it's different. This one's just saying general top 3. So with a permutation, the formula looks like this. It's going to be the number of things you have to choose from, factorial, over the number of things you have to choose from minus the number of things you are choosing, which is what? Yes. Sorry. Yes. So it's going to be 7 minus 3 on the bottom. So does everybody see how I got that? Okay. So it's this number comes from this minus the number of things you have to choose. 7 minus the number of things you have to choose. So what you're going to notice is you might kind of start getting in the hang of this. I know that the top is 7 times 5. I keep wanting to do the 5 before the 6 today. I don't know why. And I just know it's going to confuse you guys if I do that. So it's just this over this. Like that. See? So these are going to cancel. And I'm going to be left with 7 times 6 times 5, which is 210. Okay? Now, if you get in the hang of it, you'll see that when it's 7 factorial over 4 factorial, I know it's going to be 7 times 6 times 5. Do you all start seeing why that's the case? Okay. Now, what you're going to notice is when you're dealing with similar situations, you're going to notice that the permutation is going to be larger than the combination. Okay? And that's because it's more specific. Before, I was just taking the 7 people and picking a general top 3, and there's 35 ways to do that. We don't care who's in the top 3, what order they're in. Here, we're taking the 7 runners and we're placing them first, second, third. There's more ways that people can be arranged first, second, third than just general top 3. Do you guys see what I'm saying? I'm getting more specific with my arrangement, which means there's more ways I can do the arrangement. All right. Identify each solution as a permutation or combination and then find the arrangement. So from a team of 9 players, how many ways can a coach choose a captain and co-captain? Is there a difference between a captain and a co-captain? Yes, they have different duties possibly, right? So if 2 people got chosen and somebody got captain and co-captain, most likely you'd rather be captain than co-captain, right? So the order here does matter. So what's it going to be? A permutation. Because there is a difference between getting captain and co-captain. So, with a permutation, the formula is going to be a little bit different, remember? So this one right here was a permutation. This was a combination, so we're going to use the permutation formula. Top is always going to be the sample space, factorial, the number you have to choose from, over. With a permutation, how do we get our denominator? Yeah, so it's going to be the number of things that you're choosing, and we're choosing 2 different things, a captain and co-captain. So you're going to do the sample space minus the number of things you're choosing, which is 7. So this is just going to end up being 9 times what? 8, which is what? 72. So that means that if you have a team of 9 players, there's 72 ways in which you can choose a captain and a co-captain with those 9 people. You probably don't even realize there's going to be that many, right? Until you start doing the problems. All right. On to the back. Identify if each situation, same thing. A class of students is split into 8 groups of 3 students for a group project. In one class period, there's only time for 4 groups to present. And how many ways can the 4 groups be chosen to present? So, this one is one of those ones that to me, I think is hard to tell if it's a combination or a permutation. But we have to read the context of the problem. Does it say anything about it mattering who goes first, second, or third in the presentation? No, so we're just picking what 4 groups are going to be presenting today. We're not talking about what order they're presenting in, so this is just going to be a combination. So, how many groups do we have to choose from? 8. Of those 8 groups that we're choosing from, how many groups are we choosing?
4.
Good. And then we take the difference between the sample space minus the things we're choosing, which is 4. So, this right here is going to be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 4 times 3 times 2 times 1 times 4 times 3 times 2 times 1. Everybody good with how I got that? These here are going to cancel with these. And then you can just do the math from here, or you can choose to cross cancel if you're comfortable with that. Whatever you want to do. So I can do that. And then I will get anybody do the math here? Did you get 70? So there's 70 ways in which this could occur, yes.
How'd you get the 2 4s on the bottom?
That's just, oh, how did I get this, like in this? Oh, it's because of the formula. The formula for combinations is the number of things you have to choose from over the number of things you are choosing, and then times the number of things you're choosing minus the number of things you're choosing from, and 8 minus 4 happens to be 4 as well. Good?
Wait, how come you canceled 2 to the 4s out, 1 4?
You don't have to do it that way. It's just, for me, I just find it easier than having to type all this in the calculator. This is just like me doing something called cross-canceling. You may have learned about it in like Algebra 1 or before that. But if you don't like it, you can just do this divided by this whole thing. I just think the algebra is quicker for me to do it that way. But if you don't know how to do that or feel comfortable with it, just do it the way you know how to do math. Thank you. All right. So, example 5. To play in the lottery, select 5 numbers from 1 to 69. Players select 5 numbers from 1 to 69. As long as the player has all 5 numbers, they win the grand prize. So this problem right here, this sentence right here tells you if it's a permutation or combination. Based on that sentence, what do you think? It's a combination. Why is it not a permutation? Yeah, they said as long as you have all 5 numbers. So they're saying it doesn't matter if you get 1, 2, 3, 4, 5, if those are the numbers, or 5, 6, backwards, 5, 4, 3, 2, 1. Okay? So they're saying you win regardless. All right? So that's a good thing, right? You have more of an opportunity to win because your denominator is smaller in the probability. So, find the number of ways you can play or to win the lottery. So, firstly, how many numbers do we have to choose from? 69. Of those 69 numbers, how many are we picking? 5. And then what is the difference between 69 and 5? 64. Remember, combination has has 2 pieces on the bottom instead of 1. Now, mathematically speaking, I do not want to write all of this out, 69 times 68. So what I'm going to do is think logically here. What is 64 factorial going to be? It's going to be 64 times what? 3 times 60. Isn't it going to be the tail end of what 69 factorial is? So all that's going to be left of 69 factorial is the 69, 68, 67, 66, and the 65, right? Because the rest of those are going to cancel out with the 64. You guys see what I mean by that? Now, lastly, of course, we have our 5 factorial. Like that. That one's not too bad to do the math for. And then we would just do the actual math here. And that's going to give you a pretty big number. So that's 11,238,513. So, of course, that number is going to be big because do they want to make it easy to win the lottery? No, because otherwise they'd be paying people out every week, right? Yes.
I got 1,348,621,560.
You did something wrong. I did it last period too. It's definitely right.
Oh, okay, I didn't divide it.
Oh, you didn't divide it yet. That's the okay. I was gonna say. All right. So the next one says, what is the probability of winning the grand prize with an all 5 winning number? So all 5 winning number is they're saying it would just be this, like getting 5, 5, 5, 5, 5. Okay. So, getting all those 5s, there's only one way that can occur, right? Because we've decided this was a combination. So does the arrangement of the 5s matter?
No.
No, so there's only one way in which you can get all 5s. All over the total number of ways in which you can pick a number. So your chance in that happening is the chance of any of them happening, which is 1 out of the 11 million number. Not great odds, no. Any questions about that? All right, and then the last one says, if a player has at least 4 winning numbers, then they can win 50,000. What is the probability of having at least 4 winning numbers? It's actually a little bit different. It's actually a whole nother calculation. So, how many numbers do you still have to choose from? 69. How many of those do you need to actually pick now? 4. And then what's going to go here? 65. So this one's going to be 69 times 68 times 67 times 66 all over 4 times 3 times 2 times 1. And that's going to give you 8,64501. But it asks for the probability of getting that, so it's going to be 1 over that amount. So your chances of getting 4 of them is a little bit higher than your chances of getting 5, which makes sense, right? Because getting 4 is easier than getting all 5. So does everybody see how we changed the math to get the 4 instead of the 5? Okay. All right, I'm going to hand out your homework. I unfortunately didn't have a chance to make a